Hello everyone, and welcome back to Hub360 Circuit, the one-stop channel for electronics tutorials, embedded systems, and practical projects. In today's video, we'll be building a digital clock using the DS1302 real-time clock module, an I2C LCD display, and a buzzer. This project will teach you how to interface the DS1302 RTC module with Arduino, display date and time on a 16:2 LCD, set the time and date using push buttons, add sound notifications using a buzzer. By the end of this tutorial, you will have a full functional Arduino clock with adjustable time and date, perfect for your electronics decks. For this tutorial, we'll be using the following components: Arduino Uno, DS1302 RTC module, 16:2 I2C LCD display, a passive buzzer, push buttons, jumper wires, breadboard. All components are easy to source and widely available for Arduino projects at Hub360 Circuits. The DS1302 RTC module is a real-time clock module with battery backup. It keeps accurate time even when the Arduino is powered off. Common uses include digital clocks, timers and alarms, data logging system. The module communicates with Arduino via a simple 3-wire interface. How the DS1302 works: inside the DS1302 is a small oscillator and timekeeping chip that tracks seconds, minutes, hours, day, dates, months, and year. The Arduino communicates with the module to read the current time and date, set or adjust the time and date, maintain accurate time even when power is disconnected. For this project, we will use two push buttons: the mode button, which is used to cycle through time and date setting, and then the adjust button, which is used to increment selected value. The system also detects long presses to save settings to the RTC. The buzzer provides audible feedback, short beep for button press, long beep for time save. This makes the interface user-friendly. I2C LCD display. The 16:2 I2C LCD display shows the first row date, month, and year formats. Then the second row time in hours and minutes formats. During setting mode, the currently selected value blinks to indicate adjustments. First, we connect our battery to the RTC module. Then we connect the VCC of the module to 5 volts. Then we connect ground. Then we connect CLK. We connect our CLK to digital pin 4. Then we connect our DAT pin to digital pin 5. Then we connect the reset pin to digital pin 2. Now let's connect the push buttons. Now let's connect the push button. The button mode, we connect one of the pins to digital pin 3, and then we connect the second pin to ground. For the adjust button, we'll connect one of the jumper wires to digital pin 7. So for the second push button, we'll connect one of the pins to digital pin 7 on the Arduino. And then we connect the other pin to ground. For the buzzer pin, it has 3 pinouts. The first pin is the signal pin. We connect the signal pin to digital pin 8. Then we connect the second pin to VCC, which is our 5 volts. And then we connect the last pin to ground. (16:2) I2C. Now our 16:2 LCD. We connect the ground to ground. We connect the VCC to 5 volts. We connect our SDA to digital pin A4. And then we connect our LCL to digital pin A5. Now let's go to the software. First, we include our library RTC DS1302.h, and then we include the library for the LCD. Then we define the buttons. We define the push buttons. The button for the mode was pin 3 and the adjust button pin 7, and then the buzzer pin was set at pin 8. And also we define the buttons for the RTC. The IO pin was pin 4, the SCLK pin 5, and then the reset button was pin 2. Now we define the tune for the buzzer. So then we set up different modes of the clock in an enum. The mode normal, the mode set hour, the mode set minute, the mode set day, set month, and set year. The mode normal is to display the current time and date. The mode set hour is to adjust the hour. The set minute is to adjust the minute. The set day is to adjust the day. And the set month is to adjust the month. And the mode set year is to adjust the year. So we save the mode normal into a variable current mode. This helps track the current mode. And then the last mode tracks the last mode. So we created temporary variables for setting time. This stores the current RTC time. Now we set up communication with the RTC. This initializes the RTC, allows writing to RTC, and ensure the oscillator is running. Now the void handle mode button. This tells the compiler that this is the last read state of the mode button. This is the time when the button was pressed, and this is to flag to prevent multiple long press actions. And this is to read the current button state. Now, the RTC.getDate time to update the current date, and then this resets blink state and return to normal mode. And then there is a beep to indicate that the setting is safe. Now we use a switch to create and adjust the relevant value of the hour, the minutes, and also a switch case to set the day. You can see a switch case to set the month. And also that for the year. Now this is for the LCD display. Now in our void setup, we included an internal pull-up resistor for both the push buttons and then the buzzer. And then we also initialize LCD and turn on backlight. And also set up communication with the RTC. Now this is to update the blinking state and refresh the LCD display. So yeah, I'll be showing you how to use the DS1302 RTC clock module to set your time and date. So right now, the clock is in normal mode, showing the current time and date pulled directly from the DS1302 real-time clock module. To enter the settings mode, I will press the mode button once. You will notice that the day field starts blinking. The blinking tells us that this value is now selected and ready to be adjusted. Now to increase the day, I will press the adjust button. Each press increases the day by 1, and the buzzer gives a short beep to confirm the input. To move to the next setting, I press the mode button again. Now the month field is blinking, meaning we are adjusting the mode. Again, each press increases the month value. Pressing the mode button again switches to hour setting. You can see the hour digit blinking. The hour increased from 0 to 23 using a 24-hour format. One more press on the mode button takes us to minute setting. The minute digits are blinking now. Each press increases the minute value. Once all values are correctly set, we save the time by holding the mode button long press. After a short moment, you will hear a long beep. This confirms that the new date and time have been written to the DS1302 memory. The clock now automatically returns to normal mode. You can see that the time is now running normally and the blinking has stopped. Even if power is removed from the Arduino, the DS1302 continues blinking. Even if power is removed from the Arduino, the DS1302 continues keeping time using its backup battery. When power is restored, the correct time and date are still displayed. In this tutorial, you learn how to interface a DS1302 RTC module with Arduino, how to display and adjust time and date on a 16:2 LCD, how to use push buttons and a buzzer for interactive controls. If you found this tutorial helpful, like, subscribe and share. For quality Arduino boards, DS1302 modules, LCDs and electrical components, check out Hub360 circuits. Thanks for watching. See you in the next tutorial.